So let's say that we have a mass which is 2 kilograms, a force which is 10 newtons. Apparently it's the only force, so it is the total force. What is the acceleration? So the acceleration will be the total force over mass. The total force is 10 newtons over 2 kilograms. Now, I want you to know that the definition for newtons is that the newtons is kilograms meters per second squared. So, getting rid of the kilograms, we find that the acceleration would be 5 meters per second squared. Now, where do we draw the acceleration? We always draw the forces starting from the center of the mass. If we have not a point particle but a mass, the acceleration should be drawn somewhere close but not on the mass, because we don't want to confuse it with the forces, right? It has to be somewhere close, but not too close. Now, what happens if we have two forces, right? So we have two forces, and we have the same mass, and we have two forces, F1 and F2, the same direction, right? The mass is 2 kilograms. Let's say that F2 is 5 newtons and F1 is 9 newtons. Let's make it nice. Whenever the two forces have the same direction, the total force is equal to their sum. So the sum of forces would be F1 plus F2, which is 14 newtons. And the acceleration will be the total force over mass, meaning 14 divided by 2, 7 meters per second squared. What happens if the two forces are opposing? F1, F2, this being 5 newtons, this is 9. Well, the sum of forces, we said, is found by subtracting, and what we can do is we can subtract the big minus the small, so the total force will be F1 minus F2, 9 minus 5, 4 newtons. And you do understand that the direction of the total force will be the same with the direction of the big force. So the total force will be at this direction. Okay? We don't draw all of them. We don't draw all of them. We draw these, and then we can draw another particle, draw the mass as a particle, and say, all right, so here the total force has the same direction with F1 and is 4 newtons. That's the best way to do it. Now, what about the acceleration? So the acceleration apparently has the same direction with the total force, which means towards there, and also means towards the right. Does it matter if we have 3 or more? No. Depending on their direction, we add them up or we subtract them. We find the total force and divide with the mass to find the acceleration, which in this case, for example, I didn't find it. Apparently it's 4 divided by the mass 2. It will be 2 meters per second squared.